Okay, welcome dear learners to this video on simple pendulum. So in this video we'll just solve questions under simple pendulum, some from past papers, some from pamphlets, and some from textbooks. So our first question here, the question reads, find the period of a pendulum if it oscillates 15 times for 45 seconds. So we know the period of a pendulum, the formula is given, period, okay, capital T, is equal to time taken for those oscillations over n. Okay, so looking at this question, find the period of a pendulum if it takes 15, if it oscillates, okay, oscillates 15 times. So if you have a period like you have a pendulum like this, okay, so it usually oscillates between these positions of position A, B, and what C. So now the question is saying it oscillates 15 times, okay? It oscillates 15 times. Okay, now the word oscillating here, okay, don't get confused by the word. It simply means if it swings, if this bulb swings 15 times. So what do we mean when it swings 15 times? Meaning it swings like this from A to C and back to A. Now it makes these swings how many times? 15 times, okay? That is what the question is saying. So if it swings for 15 times or oscillates for 15 times, and the time it takes to swing 15 times, okay, it is what? From the question there, you can see it is 45 seconds. Okay, so this means that n is the number of oscillations, and we are told n is the number of swings, which are oscillations. So n is equal to 15. Time there, it is 45. Right? So we just replace the values here. Time is 45 seconds over the number of swings or oscillations were how many? 15. Okay, 15. Then you simply divide 45 divided by 15, you get 3. So 3 seconds. Okay, so the period of this wave is 3 seconds. Okay, 3 seconds. Let's go to the next question. So this question says the diagram shows a pendulum oscillating between positions A to C. Okay, positions A to C. So you have the diagram. Okay, so the midpoint here where the bulb is hanging, this is called the rest position. The rest position. So where it starts swinging from here, point A, it starts, okay, so it starts to swing here. That's the starting point. This is the rest position before it swings, and then it swings around like this. So it will swing from A, B, and to C. So the question says the diagram shows a pendulum oscillating between positions A to C. So it is oscillating like this from A to what? To C. So we can show this like this. It is oscillating from A to B to C. Okay, that's what the question says. Okay, that is what the question is saying. So we're told it takes 3 seconds to go from A to C. So from A to C, okay, it takes 3 seconds. So the time it takes to swing from A to C is 3 seconds. So it will swing from A to C for 3 seconds. Okay, then what is the period? That's the question. What is its period? So again, we write period is equal to time over number of oscillations. So the time we've been given, that's the 3 seconds there. So 3 seconds, then the number of oscillations or the number of swings. So when you've been given a diagram like this, it is easy to count the number of what? The number of swings. So you count the swings. One swing is from A to B, so it swings first from A to B, then B to C. This is number 2. Okay, so now A to C, okay, meaning it will swing 1, 2, okay, 2. Then you divide it over 4, okay, because the total number of swings from A to B to C and back to B and back to A, the total is 4, okay, because you're going to say 1, 2, 3, 4. Okay, now here it has only swung from A up to C, so it is 1, 2, so it is 2 over 4. And if we reduce, okay, so meaning our n, it is 2 over 4. So you can reduce this to, okay, you can simply reduce this to what? To its lowest terms. So 2 into 4, it will give you 0. What? 0.5. Okay, if you have a calculator, you can work it out like this. Okay, if you have a calculator, you can simply work it out like this. So you just count. Okay, it's one from A to C. That's what the question is. Right? It takes 3 seconds to go from A to C. What is its period? So from A to C, what is? So we want to find the number of oscillations. So 1, 2. So this is 2. Then always you divide it by 4. So meaning we're going to divide here, number of oscillations, it is 2 over 4. Okay, 2 over 4. Okay, so we can take this here. So you have 3. So this division sign will change like this. Then you have 2 over 4. Then you can put this over 1. Okay, so this is 3 over 1 times. So this sign changes to times. So that will be 4 over 2. So when the sign changes, according to fractions, these will swap. So this will be what? 12 over 2. And this now gives us, this will give us 6 seconds. Okay, that's given us 6 seconds. So the period is 6 seconds. Okay, the period is 6 seconds. All right. Then question B says, how long does it take for 12 times complete oscillations? So now they've given us the number of oscillations, right? So we're not going to count again. So here now they've said if n, okay, here now they're saying that if n is equal to 12, how long does it take for 12 times complete oscillation? So n is equal to 12. So they're saying how long. So whenever you are asked how long in physics, they're simply asking you to find the time taken. Okay, whenever you are asked to find how long in physics, so you need to know the language of physics again. How far means you're finding the distance. How long does it take? You're finding the time. Right? So we've been given n, which is t. So t, small t is what we're finding. Right? So here we're just going to solve it. We know period is equal to t over n. So the time, okay, the time we're simply was finding how long it takes. So we're just going to put t. The period we've calculated is 6 over the number of oscillations. We're told 12, okay, 12. So we're just going to put 12. Then you do this sign. So time is equal to, what is 6 by 12? Okay, so 6 by 2, that is 12. So 2 carry 1, 6 by 1, 6 plus 1, 70. So it would take 72 seconds. So this one need to take 72 seconds. Okay, and we're done solving this question. We're done solving this question. Then now we have another question. This question here says, in an experiment to determine the period of a pendulum, the time for 20 oscillations is found to be 30 seconds. Okay, so the time for 20 oscillations is found to be 20 seconds. Okay, so we're going to do this. So looking at the question, the time for 20 oscillations. So how many oscillations? Number of oscillations, that is 20. Okay, and the time we can see that is 30 seconds. What is the period? Okay, so this is simple. We're just going to say period is equal to time over n. So the time there, it is 30 seconds over n, which is 20. You divide this, you cancel that. 2 into 3, it is 1.5 seconds. And this question is done. This question is done. Okay, this question is done. Let's look at now some more questions and under the pendulum, so that we can have a better and much better understanding. So let's look at some more questions under the pendulum. So we'll look at question. We have this question here. Question 6. I've gotten it from a pamphlet. Okay, so this one is coming from a pamphlet. So let's read the question together. The diagram below shows a pendulum. Okay, so we can see a pendulum. We have the positions of the bob A, B, and C. Okay, then the question says, what is a simple pendulum? Okay, that is question A. So question A wants us to define what a simple pendulum is. Okay, so we say a simple pendulum. Okay, a simple pendulum is an instrument. Okay, instrument used to measure time. Okay, it is made up of a a bob and a string. So that's the definition of a simple pendulum. Okay, a simple pendulum is an instrument used to measure time, and it is made up of a bob and a string. Okay, so that's the definition. So question B now. Question B says the bob was found to have moved from point A to point B in 0.2 seconds, and then to point C. Calculate the periodic time. Okay, so we know period is equal to time over number of swings or oscillations. So we're told it moved from A to B. Okay, so we're going to say it moved from A to B in how many seconds? 0.2. Okay, 0.2 seconds. So from A to B it moved in 0.2 seconds. But then we see that and then to point C again. So B now it went back to C. So A to B took this seconds. The question said the bob was found to have moved from point A to point B in 0.2 seconds and then to point C. So now B to C again will be 0.2 seconds. Okay, so to find the time now, it took from A to C, you add. Okay, so it's going to be 0.4 seconds when you add 0.4 seconds. Okay, so here now what we know, you have this this diagram here. You have A, B, C. So it moved from A to B here. We are told is 0.2 seconds. So to find B to C again, it will take 0.2 seconds. So you add 0.2 by 0.2. Okay, that's how we found 0.4. Okay, that's how we found 0.4. So to find N now, okay, to find N, we're going to do this. We count the number of swings. Okay, we count the number of swings. So it swung from A to B. This is 1, and B to C. This is 2. So this is 2 over 4. So 2 over 4. Okay, 2 over 4. Okay, and then this 2 over 4, you can reduce it to, okay, 2 there 1, 2 there 2, 1 into 2. So N is equal to 0.5. Okay, so we now go to a formula. Time is 0.4, and then this is 0.5. Okay, then for this one we simply calculate. Okay, we use a calculator to calculate this. We know that physics calculators are allowed. Okay, so we divide now. 0.4 divided by 0.5. Okay, 0.4. Okay, 0.4 divided by 0.5. Okay, 0.4 divided by 0.5. This will give us 0.8 seconds. Okay, 0.8 what? Seconds, and that is the period. Okay, then the other question on the same question says, explain how the bob should move to make a complete swing. Okay, to make a complete swing. So a complete swing, okay, a complete swing is, okay, this is where the string is suspended. This is your bob, so it can move from position A to position C. So A, B, C. So a complete swing. When they say a complete swing, it's simply swinging from A to B to C and back to A. Okay, so a complete swing is what? A to B to C, okay, back to, okay, back to B to A. So A to B to C, back to B, back to A. That is what we call a complete swing. Okay, we call this a complete swing. Okay, the last question says, what do we call the time taken for the period for the pendulum to make a complete oscillation? The time taken for the pendulum to make a complete oscillation, it is called the period. So that's just the definition of a period. So period is the time taken for the pendulum to make a complete oscillation or a complete swing. Okay, that's the time. Okay, so again we have an interesting question, the last question here. So the diagram represents a pendulum hung from a fixed support. Find the length of the pendulum. Okay, we find the length of the pendulum. Okay, so the length of the pendulum, so you are just finding the length of the pendulum. Okay, the length of the pendulum. So you have the bulb there, okay, and then you have here up to here, okay, it is 10 centimeter. Okay, then where the bulb is starting, okay, so this ends up to there, okay, and then here again the whole bulb, it is 2 centimeter. So now the length, you want to find the length of the pendulum, right? The length of the pendulum is from here up to the center. So this is what we call the length of the pendulum, right? So here up to here, okay, so you are going to say 10 centimeter plus half of 2, because this is half, okay, half of this bulb, half of 2, okay, half of 2 is 1 centimeter. So meaning the length is equal to 10 plus 11, 10 plus 1 is 11 centimeter. So the length is 10 centimeter, okay, the length is 10 centimeter. Okay, so that is all in this video. If you have more questions, please you can write on the comment section, like and share, also subscribe.